Okay, hello class. So I had a question on this problem, so I thought I'd just post something about it. I'm going to use Excel, but you don't have to. This is kind of just, you kind of need to use Excel to find the standard deviation, so I guess we need to. So eat your spinach. 6 measurements were made of the mineral content in percent of spinach with the following results. It is reasonable to assume that the population is approximately normal. So here's our data. We have 6 of them. Construct a 90% confidence interval for the mean mineral content. Round the answers to 2 decimal places. Okay, so to do a confidence interval, we need the mean, the standard deviation, the critical value, or the T alpha over 2, since it's a means that we're doing. It's T alpha over 2. And the margin of error. So we need all this stuff to find the margin of error. So let's find it. We're going to find it with Excel. So the mean is the average, so equals average. Select the data, hit enter. Now I'm going to do standard deviation equals STDE, and we want the sample one, not the population one. So there's my sample one. Okay, so now I'm going to do T alpha over 2. T alpha over 2, the critical value we get from the critical table. All right, and so we have 6 sets of data. We have our n is equal to 6, which means our degrees of freedom is 5. Our degrees of freedom is 5, and then coming over to the right column, so to the right column, we want the 90% confidence level. At the bottom it says that. This is the 4th column. Going up, and I've already selected it. So there is the T alpha over 2, is this 2.015. So going back to there, 2.015 is our T alpha over 2. So with that, I can find the margin of error. Also, knowing that n equals 6, right? Because I have 6 sets of data. That's my sample size. I need that as well. So setting up this, I can use my margin of error. I'm going to use Excel since it's a calculator too. So I'm going to hit equals, and I want to take my standard deviation. So I want to take my critical value, multiply it by my standard deviation, and then divide by my square root of my sample size. And this is the formula we went over in class. So hit enter. And here's my margin of error. So I got my margin of error to find my lower limit and my upper limit for my confidence interval, which will be the bounds for my actual population mean, or what we call mu. We have we take the margin of error, we subtract it from the mean. So for the lower limit equals the mean minus the margin of error, enter. For our upper limit, we take the mean and we add it, the margin of error to it. And we hit enter. And we want to round to 2 decimal places. This is already set up for 2 decimal places, but we can round in Excel too. So my lower limit is 19.69, and my upper limit is 21.01. I click check. Boom. And we move down to the answer. That's kind of not great for what we want to write. So, but let's read over it. Based on the confidence interval, is it reasonable to believe that the mean mineral content of spinach may be greater than 22%? So, is it greater than 22% is not in here. So, since these are our percents, so these are our percents, 22% is not in here. These are both percents as well. So it is not reasonable that it's in there because we think our population mean is within these two. So it is not reasonable to believe that the mean mineral content of spinach may be greater than 22%. Okay. Also, just quickly going over megastat. we can create a confidence interval by selecting the correct stuff. So the mean, so it's confidence interval for mean. We're using a t distribution, not the z. It's our critical values, our t's, not z's for means. We select the right data for the mean. It looks like I already am, so I could select the actual place where it is for the standard deviation as well. Plug in our sample size, which is 6, and our confidence interval, which is this, and we ask for a preview. And right here, it's giving us the numbers, so, and there they are. So that's the preview. Right, it only gives you 3 digits for the preview. If you need more, click OK. And it should give us more here in the sense that it's giving quite a lot up in this region right here. Okay, but same numbers, right? The only time we'll have different numbers here is when our n is large enough that we have to round a lot for our critical value. But other than that, that's it. Okay, hope you enjoy this video. I don't know how to stop it.